Hi folks, CEO speaking again. This is the third leg about the TTL Logic Pro project. And today is about a couple of tips for the troubleshooting because I really want you to succeed in making this project. So let's start it. I have here 3 versions of the Logic Pro. This is my original made many years ago. And of course, I'm still using it. Here is the one we are talking about, the project ending today. And here is the same project on a breadboard because here I had to assemble everything to check if my reverse engineering of the diagram was working. And I took the measurements to put them in a file. And this is the most important part of today. We're going to discuss in no less than 10 minutes. Okay? Before that, we should prevent some typical, I cannot say mistakes, but omissions and corrections, and making our work with less trouble, because a lot of troubleshooting can be prevented if you pick up the right parts to make it. So because of this, let me just go back for a second on the bill of materials, and both of them, the bill of materials and the troubleshooting measurements, you're going to find them on Google Drive. I'm going to put the links in the description of the video. And from here, we're going to discuss a couple of components just to make sure we understand exactly what to do, okay? So for the display, this is the board in the top of it. This is why I'm starting with it. For the display, both the big one and the two smaller 1 inch, remember this big one is 2.3 inches size. Both I figured here, the 1 inch and the 2.3 inches, both of them are common anode. So that's important to know, okay? But what's more interesting is that if I stop the power for a second and I remove the big one like that, okay? I put it on a socket because it's much easier if you have any trouble or you have doubts about it to remove it. The other ones I didn't waste the time to put it on socket, but you can do this as well. The tip is about these contacts here. So instead of using the typical pin heads, all of us were using it either for Arduino, for Raspberry, or for any other projects. These are actually designed for the integrated circuit pins. But the pins of these displays are a bit thinner. And because of this, you won't have always a good contact on this kind of contacts here. For that reason, much better recommended are these ones machined where the pins of the display, they work much better. So, of course, exactly like any other pins, you can cut them at the length required. You have here 10 in the bottom and 9 in the top. Why 9 in the top? Because the last one on my left is the second decimal point, which is obviously missing here. Okay? So if you use this one, it's gonna be absolutely fine. So I'm gonna place it back because I just wanted you to see what kind was required. Okay, next thing to know, I provided here typical binding post connectors. I'm gonna pick up one from the bag. These ones you can order anytime. And the size of them is a typical one, 4 millimeter here inside, where you insert the cable in the post, okay? So this is 4 millimeter. Now, the thing is, to make sure they are going to stay in place, I needed a kind of support for them. as you can see here, this kind of support, the black ones I have here, you can buy the posts assembled already. I just didn't like them. So what I found was, if I'm just opening it right now, the double magnetic catch, this is exactly what's keeping in place the mechanical doors of your barbecue grill or any other mechanical doors. You can find it at any Home Depot in town. And what I did, I just removed from here the magnets and the bottom side of it. And what's remaining is exactly what you see here. And with the addition of a couple of spacers, you can see them underneath. It's a very solid arrangement. You don't have to do the same, but that was just my choice because it's extremely solid in place. Okay? Another thing which is very easy to clarify are these kind of supports for the bottom side, actually for the bottom of the second board. You can also order them anytime. I think these were made for some shelves, little shelves. I just had to provide the second hole right here because it wasn't provided, and that's it. 45 degrees oriented, and everything is very solid. It stays in place. Now another tip is, you're going to order cables for the binding posts. And the temptation is to order this kind of cables because they are typical, and this is apparently what they offer as a best compromise between price and the length. These are about 1 meter length or a bit more than 3 feet. Okay? For that particular project, I would rather recommend the shorter version because this is about 50 centimeters long, less than 2 feet long. And exactly like the long ones, it comes together with alligators, and they're very useful when you have to connect all kinds of things around you. And more importantly, it comes with the needle probes you can attach, and that's exactly the kind of probe I'm using to take the measurements. Okay? So that's perfect to take measurements. So again, as you can see, mine are much shorter, so they are less cumbersome around your measurements, and also when you connect it to the power supply. So I recommend these ones no longer than half a meter long. Okay? Next, in the diagram there is a switch. If I pick up the diagram about the decoder, there is a switch here, and what the switch does, on one position you can reset the 2 decimal points. If I just put it on, you see here the 2 decimal points. If I press this button, which is on my breadboard, is right here. So as you can see, the 2 dots are off right now. Or if I press this one in the top right here, I erase the 2 edges, the display of the 2 edges on the 2 little displays, showing me the rising or the falling. And if you put the switch, the toggle switch on the left, here is a kind of sliding switch. You won't have access to reset anymore. And for that reason, it gives a command and is going to maintain or memorize the state of these ones. So if I put the switch in the other position, like that, and let's say if I take measurements, either the positive or the ground, okay? So then I try to reset, it doesn't work anymore, you see, it remains. So this is when you want to catch a rare pulse or a pulse coming intermittently, and you wait for it for a long time. You don't have to stay there, but when you come back, you find it over here, okay? If you don't want it to be recorded, you just put the switch in the other position. So I have in the bottom here a button I can reset anytime. Now the point about this is If you take a look on the list, you're going to find as an auxiliary component a double pole, double throw toggle switch. This is the one. So when you take a look at it from a side, it has to do just toggle like this. There is another version, and it's confusing if you don't know about that. You see this one, the lever stays vertical. What is the meaning of that? Is that in one position is a momentary switch, and in the other position is the toggle, okay? So this one is a bit more confusing. It's extremely commonly used for PLCs as input simulator, okay? But in our situation, you don't need that. You just need a standard toggle switch. Any kind of toggle switch, as you can see, has 6 contacts, double pole, double throw, okay? So that's the one you need, just to make sure we understand. And then it's about the IDC connectors. Here is the box, 2x8 pin right angle IDC connector box. If it is not the right angle, it's going to stay vertical. I'm going to show you one right here. It's the same kind of connector, that's a bit bigger, but it's the same kind of box. This one stays vertical because in the moment you need to insert a board in the top of it, it's working perfectly. But here is rather recommended to be 90 degrees. It's not the end of the world if you have the straight one staying vertically, but it's going to be a bit more cumbersome, okay? So this was about the top of it. Now, if I stop the power for a second and I remove the top board, it's only taking a couple of seconds to remove it. Four little screws. Last one. Okay. Good. So if I remove this one here, you can clearly see that there is a short flat cable between the two. And of course, I've made this cable. And because the box connectors are oriented 90 degrees, then it's a bit easier to put them there. And by the way, for this one here, you remember have a video about that. Right here, make your own flat cable in minutes, okay? So this is about making the flat cable, and you can find it. Make your own flat cable in minutes, crimp IDC connectors easily, okay? Gonna stop this one, don't need it, okay? Now, there is also another one. Okay, so here is the one where you can check the display in detail. And I have the project right here, is where you can do this either automatically checking segment by segment, and you can modify the speed of it to go very slowly or to go faster. Or of course, if you remember, you can do this manually, segment by segment, including the decimal point and so on, okay? And everywhere are these boxes about and cables, so you know how to make them, okay? Now, next thing is, if we go for the board containing the input part over here, made of 6 transistors, and the decoder, you are going to notice something on the diagram. This is the input stage of the probe. And yes, there are 6 transistors, 2 groups of 3, kind of differential stages present in, that's a rudimentary form, like the ones in the operational amplifiers. And there's not a point to describe the diagram in detail. My point is to just give you a couple of practical tips in order to succeed in putting everything together. If you take a look at these 6 transistors, 2 of them here are PNP and the rest are NPN. And this may be a little problem if you're not used to take measurements over these transistors like I have them here on the breadboard. It's not easy to distinguish which of them is the NPN, which of them is the PNP if you just take a look at them from a distance, okay? Because the printing on them is very small. So I'm going to give you quickly a couple of information about that, okay? Just to make sure we understand what it is about. And there are actually 2 choices. You can use either European transistors like BC327, that's a PNP, or you can use American ones. The notation is 2N29, let's say 07, okay, 0507. Now, of course, the notations are not the same. For the European ones, B stands for silicon. A was standing for germanium. Forget about that because nobody uses them currently today. For the American ones, it's another way to identify. First of all, here, the number 2 says 2 junctions, so that's how you know it's a transistor. Because if it was a diode, it was 1N, because you only had 1 junction. The N is a kind of separating point, like you separate with the dot the name of a file and the extension. And here the number of digits present here, if there are 4 of them, is silicon. So both of them have to be, of course, silicon transistors, and that's how you know. Because if you had germanium, it was only having 3 digits instead of 4, okay? That's a completely different story. Now, what I want to tell you actually is how to make these transistors easily identifiable when you place them on the breadboard or you place them in your project. So the little tip here is this. You pick up the transistor. Let's say you order a box from, I don't know, Amazon, AliExpress, whatever you want. And then you want to identify the transistor itself. I'm going to pick up one. So I know that this one is a PNP, okay? It's a PNP. So what am I doing? I have here some shrinking tubes. I'm going to pick up a bit of it, of such a shrinking tube. And then what has to be done is that you place a bit of shrinking tube over the little transistor, and with using your iron, you just heat it up until it won't fall down from the transistor, okay, like this. And then, of course, you can easily cut it, and it's going to look exactly like this one here. I already have in my box. So when this transistor has, let's say, a green shrinking tube over it, it means what? It's different from the others, okay? So being different from the others, it tells you right away, like here on the project, I have one here and another one here. So both transistors there, you can see Q4 and Q5 in this order, Q4 and Q5. These are the PNP. The other 4 are NPN, but this is the way I identify. If you want to do more, because for your measurements, the most important part is going to be here, the 2 outputs, the collector of the transistor Q3 and collector of transistor Q6. What you can also do is just to put another shrinking tube on these 2 transistors, other colors, like blue and red, let's say, okay? This way you can clearly identify which is which. Because otherwise, if you just take a look at them and you want to measure, you want to do the troubleshooting, it's going to be difficult to do this if you don't know, okay? So that was another good tip, just to make sure we know how to identify the components. So that being said, I'm going to connect them back. Remember the connectors, the boxes, they have a notch, they have to align with each other. So then it's going to be very easy to do the job, okay? So when I give it power, of course, it's going to work just fine. And remember, if I have to connect them to measure pulses, for instance, okay, then it's going to be able either to show you low, high, if you can watch the frequency, or if you just move the switch, it's going to just show you the pulses, and you have the two edges moving left and right, okay? So this was about components, okay? Now, talking a bit about the diagram, what basically the input stage is doing, the voltage is coming here at the input of the probe when you take a measurement. It can be any voltage between 0 volts and 5 volts. You'll never know exactly what value you measure in a circuit, especially when you have to do troubleshooting, okay? Because you cannot force these parts you want to measure to be exactly 0 logic 0 volts and 1 logic 5 volts. Any voltage can be there between 0 to 5. And that's exactly the purpose of the two halves of the stages for the input, to appreciate that. And in my collection, there is another video here saying TTL voltage levels for high and low. And there I'm discussing exactly what does it mean 0 logic and 1 logic, okay? Now, what's important is if you pass over this and you go on the list of measurements, this is the most interesting part for today, because I took my time to measure a couple of times on the breadboard to make sure that the measurements are right, and I'm giving you the chart of these measurements. What you see here are the measurements on a very functional probe. This part from here to here is only about the input stage, and from here down to the end of it is about the decoder. What's interesting to see is that I highlighted it. The collector of Q3 and the collector of Q6. Collector of Q3 is here, collector of Q6 is here. So these 2 points are essential because they are going to become the inputs of the decoder. So they are going to enter exactly here, collector of the Q3 and collector of the Q6, and they enter in the decoder. And the result of your measurements for a functional probe, it should be this. In the collector of the Q3 and Q6, if there is a limbo state meaning, or the equivalent of the fact that my probe is not connected anywhere, or my signal shows a measurement anywhere between 0 logic and 1, so it's neither of them, then you should have on the collector of Q3 and collector of the Q6, you should have 0, respectively 1 logic. But instead of giving you 0 logic and 1 logic, I'm giving you the measurement taken with the multimeter to make sure that you have a pretty close one to that, okay? If there is a low, like here I'm connecting, if I'm connecting my logic probe to 0 logic, like here, okay? It shows a low on my probe, but then on the two collectors, Q3 and Q6, you should find on both 5 volts, see? 5 volts. So this is when you measure low. And when you measure high, it's going to be something like this. You measure high, then you have to have 0 on the collector of Q3 and 0 on the collector of Q6, 0 on both. So the 3 sets of measurements, these ones are identifying the logic levels you are going to get in your circuit depending on what logic state you measure, okay? So then, on the right side, you have something I call replica. This is gonna be your own project. So now I've made mine, this one here, the desktop logic probe. Of course, I did some mistakes. It's inevitable, everybody's going to do. So here I started to take my measurements until I identified what was not exactly the same as it was in the original project. So I was able to fix the missing links on the wrong ones. I did a couple of short circuits accidentally. And it was easy to fix them because I had all the measurements I put on my replica. So the three columns for limbo, low, and high for your replica, they have to match, let's say, plus minus 5% to the ones I've given you here. So there are measurements on 2 pages, okay? And you have the code of the integrated circuit and the pin number you take the measurement on, okay? So this is the most important thing. In very few places you're going to find this kind of thing, measurements taken. Last detail about these measurements is the sliding switch is on no memory, because the sliding switch, remember, when you pick up the diagram and you take a look at the sliding switch, I didn't need to use a sliding switch. The sliding switch was only present on my original probe, the miniature one. This is why it's a sliding switch, okay? But here you can use a toggle switch. It's much easier to place it on your project, a toggle switch. So you place a toggle switch to not be on the memory. Remember, on the memory is when you can use the push button to give a reset. So you can check this. Here, I cannot reset it, so this is not resettable because the switch is on the memory. And of course, if I remove it from here and I press the button now, I can reset. So that's exactly what I'm seeing here, the sliding or the toggle switch on no memory. So if you do this, it's going to be relatively easy to just follow these measurements and your project has all the chances to work fine, okay? So I have here 3 probes again. Conclusion, the original one I used to restore the diagram, which was lost many years ago. I checked it here on the breadboard, and talking about the breadboard, you can see there are 2 capacitors. These 2 capacitors were only required for the half a second pulse given by the monostable circuits inside the package 123. When you check the project on a breadboard, it's not important what kind of capacitors you have if you just respect the size of it, meaning 33 microfarads. But I preferred, when placing the components on the probe itself, to have them like here, tantalum, these droplet shape tantalum capacitors, because they have practically very little leakage, practically no leakage. And it was pretty similar here. I have 2 little droplets here across the package 123, okay, instead of the classical electrolytic ones, aluminum based, okay? So if you have any additional questions, of course, you can ask me anytime. But again, I have the original probe, the one on the breadboard where you can check all the components, then you can remove them and keep them aside until you have your parts placed on the real boards. And talking about the real boards, you can have single side prototyping board like this one. So you can solder only on one side. This is what I used for the display. But of course you can use one double-sided like this. So I use the double side to show you you can use both. I use a double side for the decoder and for the input part. And it's recommended to have some, let's say, couple of spares, because exactly like what happened to me, the first measurements I did when I drilled the holes, I did a couple of mistakes any of us may do. And because of this, I had to correct the measurements again. And the second time I did it, there was no mistake anymore. But this one is looking much nicer. And this one, for me, is a scrap. I'm only showing it to you to see that. It may happen to anybody, okay? So this being said, that's the Logic Pro project. Now you have all the measurements available. Thank you very much for today, and I'm gonna see you next time for another video. Bye-bye.